Question 100. What does fine-tuning an LLM mean? Option A. Compressing the model to reduce its size. Option B. Further training a pre-trained model on a smaller, task-specific dataset to specialize its behavior. Option C. Connecting the model to external databases. Option D. Adjusting the model's temperature and top P settings. The correct answer is B. Further training a pre-trained model on a smaller, task-specific dataset to specialize its behavior. Fine-tuning continues training a pre-trained LLM on a curated dataset for a specific task or domain, adjusting its weights to improve performance on that target use case. Question 101. What is retrieval augmented generation (RAG)? Option A. A fine-tuning method using synthetic data. Option B. A way to reduce LLM inference costs by caching responses. Option C. A method of training LLMs specifically on retrieval tasks. Option D. A technique combining external document retrieval with LLM generation to improve factual accuracy. The correct answer is D. A technique combining external document retrieval with LLM generation to improve factual accuracy. RAG retrieves relevant documents from a knowledge base at inference time and provides them as context to the LLM, enabling it to answer questions with up-to-date or domain-specific information without retraining. Question 102. What is RLHF reinforcement learning from human feedback? Option A. A way to compress LLMs using human-defined rules. Option B. A retrieval technique that uses human-curated knowledge bases. Option C. A training technique where human raters score model outputs. A reward model is trained on those scores, and that reward model is used to fine-tune the LLM via RL. Option D. A method of collecting training data from websites. The correct answer is C. A training technique where human raters score model outputs. A reward model is trained on those scores, and that reward model is used to fine-tune the LLM via RL. RLHF trains a reward model from human preference data, then uses RL, typically PPO, to fine-tune the LLM to produce outputs that score highly according to that reward model, used in ChatGPT and Claude. Question 103. What does top P nucleus sampling control? Option A. The probability threshold. Only tokens whose cumulative probability reaches P are considered for sampling. Option B. The maximum length of the model's context window. Option C. The number of tokens the model considers before stopping generation. Option D. The learning rate during fine-tuning. The correct answer is A. The probability threshold. Only tokens whose cumulative probability reaches P are considered for sampling. Top P sampling restricts sampling to the smallest set of tokens whose cumulative probability equals P, e.g., 0.9. This balances diversity and coherence better than fixed top K. Question 104. What is the difference between encoder-only and decoder-only transformer models? Option A. Encoder-only models, e.g., BERT, are best for understanding tasks. Decoder-only models, e.g., GPT, are best for text generation. Option B. They are identical, the names just reflect training data differences. Option C. Encoder-only models ooze attention. Decoder-only models do not. Option D. Encoder-only models are larger. Decoder-only models are smaller. The correct answer is A. Encoder-only models, e.g., BERT, are best for Question 105. What is in-context learning in LLMs? Option A. The ability of LLMs to perform new tasks by providing examples within the prompt, without updating model weights. Option B. Caching previous conversation turns for faster inference. Option C. A method of reducing the context window to save memory. Option D. Training the model on new data within the context window. The correct answer is A. The ability of LLMs to perform new tasks by providing examples within the prompt, without updating model weights. In context learning lets an LLM adapt to new tasks purely through examples in the prompt, few shot, or instructions 0 shot, without any gradient updates to model weights. Question 106. What is chain of thought (CoT) prompting? Option A. A technique for reducing hallucinations by chaining verification prompts. Option B. Prompting the model to show intermediate reasoning steps before giving a final answer, improving accuracy on complex tasks. Option C. Repeating the same prompt multiple times to reduce errors. Option D. A method for compressing long prompts into shorter ones. The correct answer is B. Prompting the model to show intermediate reasoning steps before giving a final answer, improving accuracy on complex tasks. Chain of thought prompting encourages the model to reason step by step before answering. This significantly improves performance on arithmetic, logic, and multi-step reasoning tasks. Question 107. What is the purpose of embeddings in LLMs? Option A. To convert tokens into dense numerical vectors that capture semantic meaning and relationships. Option B. To limit the number of tokens in the context window. Option C. To store the model's training data in compressed form. Option D. To assign a unique ID number to each word in the vocabulary. The correct answer is A. To convert tokens into dense numerical vectors that capture semantic meaning and relationships. Embeddings map tokens to high-dimensional vectors where semantically similar words are close together. They are the first layer of an LLM and form the foundation for all downstream processing. Question 108. What is quantization in the context of LLM deployment? Option A. Reducing the number of parameters in the model. Option B. Converting the model to run on a different programming language. Option C. Reducing the precision of model weights, for example from 32-bit to 4-bit to decrease memory usage and speed up inference. Option D. Adding safety filters to the model output. The correct answer is C. Reducing the precision of model weights, for example from 32-bit to 4-bit to decrease memory usage and speed up inference. Quantization reduces the numerical precision of weights, for example from float 32 to int 8 or int 4, dramatically reducing memory footprint and increasing inference speed with minimal accuracy loss. Question 109. What does zero-shot prompting mean? Option A. Running the model with temperature set to 0. Option B. A technique that sets all model weights to 0. Option C. Giving the model 0 context about the task. Option D. Asking the model to perform a task with no examples provided, relying solely on its pre-trained knowledge. The correct answer is D. Asking the model to perform a task with no examples provided, relying solely on its pre-trained knowledge. Zero-shot prompting asks the model to complete a task described only in natural language, with no worked examples. It tests the model's ability to generalize from pre-training alone. Question 110. The correct answer is B. A malicious technique where crafted user input attempts to override or hijack the model's original system instructions. Prompt injection is an attack where a malicious user embeds instructions in their input to override the system prompt or make the model behave in unintended ways, a key security concern in LLM applications. Question 111. What is the attention is all you need insight that makes transformers powerful? Option A. Replacing positional encodings with learned attention weights. Option B. Using attention only in the final layer of the network. Option C. Self-attention allows every token to directly attend to every other token in the sequence, enabling parallel processing and capturing long-range dependencies without recurrence. Option D. Replacing all matrix multiplications with attention operations. The correct answer is C. Self-attention allows every token to directly attend to every other token in the sequence, enabling parallel processing and capturing long-range dependencies without recurrence. Transformers replace sequential RNN processing with self-attention, where each token can directly attend to all others simultaneously. This enables full parallelization during training and captures long-range dependencies far more effectively than RNNs. Question 112. What is the computational complexity of standard self-attention with respect to sequence length n? Option A. O(n)(3). Option B. O(n) log n. Option C. O(n). Option D. O(n)(2). The correct answer is D. O(n)(2). Standard self-attention computes pairwise attention scores between all token pairs, resulting in O(n)(2) time and memory complexity. This is the main bottleneck for very long sequences, motivating sparse and linear attention variants. Question 113. What is LoRA low rank adaptation and why is it used? Option A. A knowledge distillation method that creates smaller student models. Option B. A quantization technique that reduces model size. Option C. A parameter-efficient fine-tuning technique that adds small trainable low-rank matrices to frozen model weights, drastically reducing fine-tuning compute and memory. Option D. A retrieval method for augmenting LLMs with external knowledge. The correct answer is C. A parameter-efficient fine-tuning technique that adds small trainable low-rank matrices to frozen model weights, drastically reducing fine-tuning compute and memory. LoRA freezes the original model weights and injects trainable low-rank decomposition matrices into attention layers. Only these small matrices are trained, reducing trainable parameters by 10,000x plus while matching full fine-tuning quality. Question 114. What is emergent behavior in large language models? Option A. Behaviors explicitly programmed during pre-training. Option B. Capabilities that unpredictably appear at certain model scales that were not present in smaller models and were not directly trained for. Option C. Hallucinations that emerge as models become larger. Option D. The model's ability to follow system prompts accurately. The correct answer is B. Question 115. What is the role of positional encodings in transformers? Option A. To reduce the dimensionality of the token embeddings option B. To initialize the model weights before training option C. To control the output probability distribution of each token option D. To inject information about the position of each token into the input embed. The correct answer is D. To inject information about the position of each token into the input embeddings. Since self-attention is permutation invariant by default, self-attention has no inherent notion of order. It treats the input as a set, not a sequence. Positional encodings add position information to token embeddings so the model can distinguish token order. Question 116. What is constitutional AI? AI is developed by Anthropic. Option A. A training method where an AI critiques and revises its own outputs according to a set of principles, a constitution, reducing the need for human feedback on harmful content. Option B. A dataset curation technique that filters training data using predefined rules. Option C. A hardware design for running AI models on specialized chips. Option D. A legal framework governing how AI companies use training data. The correct answer is A. A training method where an AI critiques and revises its own outputs according to a set of principles, a constitution, reducing the need for human feedback on harmful content. Constitutional AI. Anthropic 2022 trains models to self-critique and revise their outputs using a set of natural language principles. This reduces reliance on human labelers for harmful content and forms part of Claude's training. Question 117. What is perplexity as a metric for evaluating language models? Option A. A measure of how well the model predicts a held-out text sample. Lower perplexity means the model assigns higher probability to the actual next tokens. Option B. The proportion of hallucinated facts in model outputs. Option C. The number of distinct tokens the model has seen during training. Option D. The total number of parameters in the model. The correct answer is A. A measure of how well the model predicts a held-out text sample. Lower perplexity means the model assigns higher probability to the actual next tokens. Perplexity is the exponentiated negative log likelihood of a test set. A lower perplexity means the model is less surprised by the test data. It is a standard intrinsic LLM benchmark. Question 118. What is speculative decoding in LLM inference? Option A. A training technique that generates synthetic data for fine-tuning. Option B. A sampling method that speculatively reduces the context window size. Option C. A small draft model generates tokens quickly. The large model verifies them in parallel, speeding up inference without changing output quality. Option D. Generating multiple candidate outputs and selecting the best one. The correct answer is C. A small draft model generates tokens quickly. The large model verifies them in parallel, speeding up inference without changing output quality. Speculative decoding uses a fast small model to draft several tokens. Then the large model verifies all of them in a single forward pass. Accepted tokens are kept, rejected ones are resampled. This achieves 2-3x speedup with identical output quality. Question 119. What distinguishes instruction-tuned models from base pre-trained LLMs? Option A. Instruction-tuned models have more parameters than base models. Option B. Base models are better at following user instructions than instruction-tuned ones. Option C. Fine-tuned on instruction response pairs to follow directions. Base models only predict the next token. Option D. They are identical. Instruction tuning only changes. The correct answer is C. Fine-tuned on instruction response pairs to follow directions. Base models only predict the next token. Base models are trained purely on next token prediction and are not optimized to follow instructions. Instruction tuning via supervised fine-tuning and /or RLHF aligns the model to helpfully respond to user requests. Question 120. What is the scaling law in LLMs as described by Kaplan et al. 2020? Option A. All LLMs must reach 1 billion parameters to be useful. Option B. Larger models always hallucinate more than smaller ones. Option C. Scaling laws only apply to image generation models. Option D. Model performance improves as a power law with model size, data, and compute enabling performance prediction before training. The correct answer is D. Model performance improves as a power law with model size, data, and compute enabling performance prediction before training. Kaplan et al. Found that LLM loss follows predictable power laws with model size, data, and compute. This enabled labs to extrapolate performance at larger scales before committing to expensive training runs. Question 121. What is prompt engineering? Option A. Writing training data for LLMs. Option B. Writing code to deploy LLMs in production. Option C. Choosing which LLM provider to use. Option D. Designing and refining input instructions to get the best outputs from an LLM without changing model weights. The correct answer is D. Designing and refining input instructions to get the best outputs from an LLM without changing model weights. Prompt engineering is the skill of crafting clear, well-structured inputs to guide an LLM toward accurate, useful, and relevant responses without updating any model weights. Question 122. What is zero-shot prompting? Option A. Asking the model to perform a task with no examples provided in the prompt. Option B. Asking the model to double-check its own answer. Option C. Providing context to the model before the question. Option D. Setting temperature to 0 for deterministic output. The correct answer is A. Asking the model to perform a task with no examples provided in the prompt. Zero-shot prompting asks the model to complete a task using only unnatural language instruction, with no worked examples, relying purely on the model's pre-trained knowledge. Question 123. What is few-shot prompting? Option A. Asking multiple different models the same question. Option B. Limiting the model to generating only a few tokens. Option C. Using the shortest possible prompt. Option D. Providing a small number of input-output examples in the prompt to guide the model's style or response. The correct answer is D. Providing a small number of input-output examples in the prompt to guide the model's style or response. Few-shot prompting includes 2-5 worked examples in the prompt, showing the model the desired format and reasoning pattern before asking the actual question. Question 124. What does chain-of-thought (COT) prompting do? Option A. Chains together several separate prompts into one document. Option B. Connects multiple LLMs in a pipeline. Option C. Encourages the model to show step-by-step reasoning before giving the final answer. Option D. Restricts the model to a single-word answer. The correct answer is C. Encourages the model to show step-by-step reasoning before giving the final answer. Chain-of-thought prompting adds phrases like "let's think step-by-step" to Question 125. What is a system prompt? Option A. Instructions given to the model before the user conversation to set its role, tone, or behavior. Option B. The final message the model sends before ending a conversation. Option C. A prompt written entirely in code. Option D. A prompt that only the system administrator can see the response to. The correct answer is A. Instructions given to the model before the user conversation to set its role, tone, or behavior. A system prompt is a hidden instruction provided to the LLM before the user's first message. It defines the model's persona, constraints, format, and context for the entire conversation. Question 126. What is role prompting? Option A. Defining a custom tokenization role. Option B. Asking the model what its own role or purpose is. Option C. Instructing the model to adopt a specific persona or expertise, e.g., you are an expert doctor. Option D. Assigning different team members different LLM accounts. The correct answer is C. Instructing the model to adopt a specific persona or expertise, e.g., you are an expert doctor. Role prompting assigns a persona or expertise to the model. This primes it to respond with domain-specific knowledge and the appropriate tone, improving output quality for specialized tasks. Question 127. Which of the following is an example of good prompt practice? Option A. Being specific, providing context, and stating the desired output format clearly. Option B. Repeating the same instruction many times in one prompt. Option C. Using as much technical jargon as possible. Option D. Keeping prompts as short as possible at all times. The correct answer is A. Being specific, providing context, and stating the desired output format clearly. Good prompts are specific about the task, provide relevant context, specify the desired format, for example bullet points, JSON, and include any constraints, reducing ambiguity and improving outputs. Question 128. What does temperature control in LLM generation? Option A. The number of tokens the model can remember. Option B. The randomness of outputs. Lower means more predictable, higher means more creative. Option C. The speed at which the model generates tokens. Option D. The length of the model's response. The correct answer is B. The randomness of outputs. Lower means more predictable, higher means more creative. Temperature scales the probability distribution over the next token. A temperature of 0 makes the model deterministic, always picks the most likely token. Higher values increase randomness and creativity. Question 129. What is prompt injection? Option A. A technique to increase the number of tokens processed. Option B. A malicious attack where crafted input tries to override the model's system instructions. Option C. A way to speed up model responses by shortening prompts. Option D. A method to inject external APIs into the prompt. The correct answer is B. A malicious attack where crafted input tries to override the model's system instructions. Prompt injection is a security attack where malicious text in a user input attempts to hijack or override the model's original system instructions, making it behave in unintended ways. Question 130. What is the purpose of adding output format instructions in a prompt? Option A. To reduce the number of tokens used. Option B. To make the model respond faster. Option C. To change. The correct answer is D. To tell the model how to structure its answer, e.g., JSON, bullet points, table specifying the output format. For example, respond in JSON. Use bullet points. Write a table ensures the model's response matches what your application or user expects. Question 131. What is retrieval augmented prompting, RAP/RAG? Option A. Asking the model to retrieve information from its own weights. Option B. A technique for compressing long prompts. Option C. A method of training the model on retrieved documents. Option D. Fetching relevant documents at inference time and including them as context in the prompt to ground the model's answer. The correct answer is D. Fetching relevant documents at inference time and including them as context in the prompt to ground the model's answer. RAG retrieves relevant documents from a knowledge base and injects them into the prompt context, allowing the model to answer with up-to-date or domain-specific information without retraining. Question 132. What is self-consistency prompting? Option A. A technique that keeps the model's tone consistent across turns. Option B. Generating multiple reasoning chains independently and selecting the most common answer, improving robustness. Option C. Using the same prompt across different models. Option D. Checking that the model agrees with its previous answer. The correct answer is B. Generating multiple reasoning chains independently and selecting the most common answer, improving robustness. Self-consistency samples multiple chain-of-thought reasoning paths, then takes a majority vote over the final answers. This reduces variance and improves accuracy on reasoning tasks. Question 133. What is tree of thoughts to T prompting? Option A. An extension of chain of thought that explores multiple reasoning branches simultaneously, evaluating and pruning paths to find the best solution. Option B. A technique for generating decision trees as model output. Option C. A method of organizing prompts in a hierarchical folder structure. Option D. A way to visualize token probabilities as a tree. The correct answer is A. An extension of chain of thought that explores multiple reasoning branches simultaneously, evaluating and pruning paths to find the best solution. Tree of thoughts allows the model to explore multiple reasoning branches at each step, backtrack from dead ends, and evaluate intermediate states, making it far more powerful for complex planning tasks. Question 134. What is prompt chaining? Option A. Breaking a complex task into smaller subtasks, where the output of one prompt becomes the input of the next. Option B. Sending the same prompt to multiple models at once. Option C. Linking prompts using mathematical chains. Option D. Using the same prompt repeatedly until the answer improves. The correct answer is A. Breaking a complex task into smaller subtasks, where the output of one prompt becomes the input of the next. Prompt chaining decomposes complex workflows into sequential prompts. Each prompt handles one step, and its output is passed as context to the next, improving accuracy and allowing error checking between steps. Question 135. What is the ReACT prompting framework? Option A. A framework combining reasoning and acting. The model alternates between thinking through a problem and taking actions like web search to solve it. Option B. A method for making models emotionally reactive. Option C. A prompting style that removes all reasoning from the output. The correct answer is A. A framework combining reasoning and acting. The model alternates between thinking through a problem and taking actions like web search to solve a tree. ACT reason plus ACT interleaves reasoning traces with tool use actions. The model thinks, acts, searches, calculates, observes the result, then thinks again, enabling complex multi-step problem solving. Question 136. What is few-shot vs fine-tuning? When should you prefer few-shot? Option A. Few-shot suits quick adaptation with no retraining. Fine-tuning is better for consistent style, large datasets, or lower latency. Option B. Few-shot is always better than fine-tuning in every situation. Option C. Fine-tuning is always cheaper than few-shot prompting. Option D. They produce identical results. Choose based on preference. The correct answer is A. Few-shot suits quick adaptation with no retraining. Fine-tuning is better for consistent style, large datasets, or lower latency. Few-shot prompting requires no training and works well for varied tasks with good examples. Fine-tuning is better when you have large task-specific datasets, need consistent behavior at scale, or want lower inference latency. Question 137. What is negative prompting? Option A. Using negative language to make the model disagree with everything. Option B. A technique used only in image generation, not text LLMs. Option C. Explicitly telling the model what not to do, include, or say in its response. Option D. Giving the model a low temperature setting. The correct answer is C. Explicitly telling the model what not to do, include, or say in its response. Negative prompting specifies constraints by telling the model what to avoid, e.g., do not use jargon, do not mention competitors. This is especially powerful in image generation models like Stable Diffusion. Question 138. What is persona prompting used for in business applications? Option A. Assigning the model a consistent character, expertise, and communication style to power branded AI assistants or specialized bots. Option B. Making the model pretend to be human to pass the Turing test. Option C. Letting users choose their own AI's name only. Option D. Training the model on custom personas. The correct answer is A. Assigning the model a consistent character, expertise, and communication style to power branded AI assistants or specialized bots. Persona prompting defines a consistent identity for the LLM, e.g., your area, a friendly customer support agent for Tech Corp. This enables branded, specialized AI products with consistent tone and knowledge. Question 139. What is contextual compression in prompt engineering? Option A. A technique to reduce GPU memory during inference. Option B. Summarizing or filtering retrieved documents before inserting them into the prompt to use the context window more efficiently. Option C. Compressing the prompt into a shorter representation using another model. Option D. Reducing the model size to fit smaller context windows. The correct answer is B. Summarizing or filtering retrieved documents before inserting them into the prompt to use the context window more efficiently. Contextual compression uses a secondary model or algorithm to extract only the most relevant parts of retrieved documents before adding them to the prompt, reducing context window usage and improving focus. Question 140. What is the purpose of delimiters in prompt engineering? Option A. To encrypt sensitive parts of the prompt. Option B. To clearly separate different sections of a prompt, for example instructions, context, input using markers like triple quotes, XML tags, or dashes, reducing ambiguity. Option C. To make the prompt look more visually appealing. Option D. To indicate where the model should stop generating. The correct answer is B. To clearly separate different sections of a prompt, for example instructions, context, input using markers like triple quotes, XML tags, or dashes, reducing ambiguity. Delimiters like triple backticks, XML tags, or dashes clearly separate prompt sections, instructions, context, user input, preventing the model from confusing one section for another. Question 141. What is automatic prompt optimization APO? Option A. Choosing the shortest prompt that fits the token budget. Option B. Using algorithms or LLMs themselves to automatically search, evaluate, and improve prompts based on performance metrics on a validation set. Option C. Automatically translating prompts into multiple languages. Option D. Optimizing the model weights based on prompt feedback. The correct answer is B. Using algorithms or LLMs themselves to automatically search, evaluate, and improve prompts based on performance metrics on a validation set. APO treats the prompt text as a learnable variable. Methods like ProTG, DSPy, and Opro use LLMs to generate prompt candidates, evaluate them against gold labels, and iteratively refine the best performing prompts. Question 142. What is DSPy and how does it change prompt engineering? Option A. A dataset for evaluating prompt engineering techniques. Option B. A framework that replaces handwritten prompts with declarative programming, defining the task signature and letting the system compile optimized prompts and few-shot examples automatically. Option C. A Python library for visualizing prompt token probabilities. Option D. A library for deploying LLMs as microservices. The correct answer is B. A framework that replaces handwritten prompts with declarative programming, defining the task signature and letting the system compile optimized prompts and few-shot examples automatically. DSPy Stanford lets developers declare what a module should do rather than writing prompts manually. A DSPy compiler optimizes prompts and few-shot examples automatically using training data and a metric. Question 143. What is faithfulness vs factuality in LLM output evaluation? Option A. Faithfulness only applies to summarization tasks. Option B. They are synonyms, both mean the output is correct. Option C. Faithfulness is about tone. Factuality is about length. Option D. Faithfulness measures whether the output is consistent with the provided context. Factuality measures whether the output is true according to real-world knowledge. The correct answer is D. Faithfulness measures whether the output is consistent with the provided context. Factuality measures whether the output is true according to real-world knowledge. Faithfulness or groundedness asks, is the answer consistent with the given context? Factuality asks, is the claim true in the real world? A model can be faithful to a wrong document, or factual but unfaithful to the question 144. What is prompt sensitivity and why is it a problem? Option A, small changes to wording, punctuation, or example order can cause large, unpredictable changes in LLM output. Option B, the ability of a prompt to work across multiple languages. Option C, the degree to which a prompt reveals private information. Option D, the sensitivity of a model to the temperature setting. The correct answer is A, small changes to wording, punctuation, or example order can cause large, unpredictable changes in LLM output. LLMs are highly sensitive to surface-level prompt variations. Changing word order, punctuation, or example ordering can dramatically change outputs. This makes prompt engineering non-deterministic and hard to reliably reproduce. Question 145. What is constitutional prompting inspired by constitutional AI? Option A, a prompting method for writing legal constitutions. Option B, using government regulations as prompt guidelines. Option C, a technique that restricts the model to only formal language. Option D, providing principles and asking a model to critique and revise its own outputs against those principles before finalizing. The correct answer is D, providing principles and asking the model to critique and revise its own outputs against those principles before finalizing. Constitutional prompting applies CUAI principles at inference time. Prompt the model to generate a response, then ask it to critique the response against a set of principles and revise accordingly. Question 146. What is the lost in the middle problem in long context prompting? Option A, a hallucination pattern that only appears in long outputs. Option B, the empirical finding that LLMs perform worse at retrieving information placed in the middle of a long context compared to information at the beginning or end. Option C, when the model loses track of the conversation after many turns. Option D, when the model runs out of context window mid-generation. The correct answer is B, the empirical finding that LLMs perform worse at retrieving information placed in the middle of a long context compared to information at the beginning or end. Liu et al. 2023 found that LLMs have a U-shaped recall curve over long context. They reliably recall information near the start and end, but often miss critical information placed in the middle. This affects RAGE and long document prompting. Question 147. What is meta-prompting? Option A, using an LLM to generate, evaluate, or improve prompts for another task, essentially prompting a model to prompt itself or another model. Option B, a technique for writing prompts in multiple languages simultaneously. Option C, writing prompts about the history of prompt engineering. Option D, a method of embedding prompts directly into model weights. The correct answer is A, using an LLM to generate, evaluate, or improve prompts for another task, essentially prompting a model to prompt itself or another model. Meta-prompting uses an LLM as a prompt designer, e.g., write me the prompt that would help an LLM solve this type of maths problem. This automates prompt creation and is foundational to APO frameworks. Question 148. What is the hallucination snowball effect in multi-turn prompting? The correct answer is C. An early hallucination gets included in subsequent context, causing the model to build on false premises and compound errors over later turns. In multi-turn conversations, early incorrect statements remain in the context window and become facts the model builds upon. Each subsequent turn can amplify the original error, compounding hallucinations with each response. Question 149. What is skeleton of thoughts OT prompting? Option A, a technique where the model first generates a high-level outline skeleton, then fills in each section in parallel, reducing latency compared to sequential generation. Option B, a method of pruning chain of thought steps after generation. Option C, a prompt format for generating structured JSON outputs. Option D, a chain of thought variant that generates only the key reasoning steps. The correct answer is A, a technique where the model first generates a high-level outline skeleton, then fills in each section in parallel, reducing latency compared to sequential generation. So Ning et al. 2023 prompts the model to first produce a skeleton, then expands each section into an answer in parallel using batch inference. This reduces end-to-end latency for long-form generation by 2x or more. Question 150. What is soft prompting prefix tuning / prompt tuning and how does it differ from hard prompting? Option A, Soft prompting is another name for few-shot prompting. Option B. Soft prompts are trainable continuous vectors optimized via gradient descent, not human-readable text, unlike discrete hard prompts. Option C. Soft prompts are shorter than hard prompts. Option D. Using polite language in prompts versus direct instructions. The correct answer is B. Soft prompts are trainable continuous vectors optimized via gradient descent, not human-readable text. Unlike discrete hard prompts, soft prompts are trainable continuous embeddings prepended to the input, not human-readable text. They are optimized via backpropagation on task-specific data like fine-tuning, but cheaper. Hard prompts are discrete text tokens written by humans.